Hello, grade 11s. Welcome. So first things first, I would like to ask you is that please get a notepad or a book or a pen and paper so that you can write down as we go through this video. If you hear something, just write it down. It helps with memory retention. So, and another thing that I would like to say is if you find yourself struggling with this chapter, I'm just here to say I understand. I also struggled with it as a student. I actually found grade 11 geography more difficult than grade 10 and 12 geography, but you will see that it is actually not as difficult as it seems. And another disclaimer that I would like to make, I will tell this as a story and not necessarily use the technical terms that I used in the textbook so that you understand better. But once you understand and you have a picture of what's happening, then you can go back into the textbook with the terminology so that you can be able to answer your exams more effectively, because the terminology can be a bit daunting and you're just like, okay, wait, what's happening? So yeah, without wasting more time, let's get into the video. So the uneven energy balance can be attributed to several factors, but one of the first factors is the shape of the earth, and that is the spherical shape of the earth. So I should have bought a sphere, but I unfortunately do not have one, but this is the earth, and the sun's rays shine perpendicular to the earth, and because of that, because of the spherical nature, because of the angle at which the sun's rays shine on Earth, that is already a reason for the uneven heat or solar rays distribution. So areas that are found on the equator will receive more solar energy, the sun's rays, because of the angle. They are more exposed to the sun in comparison to areas that are down here or up here, which are okay. I'm sorry about that. I do not know what happened, but anyways, so now the poles will be colder because of that, and the equator will be warmer because of that, because of the incoming solar energy / sun's rays. So yeah, so because of that, the poles have snow. That's another factor. The fact that snow has a high albedo, which is basically the reflectivity. So the incoming solar rays are reflected back because of the surface. Whereas on the equator, the earth, the ground, the soil is dark, and that absorbs the solar energy. So that is another reason why areas in the equator / the tropics will receive more or will have warmer temperatures because of those factors. So yeah, that's just a story, a picture of, just some of the reasons why there's uneven heat distribution. I'm sure by now you've noticed that there's differences in seasons. Some places will experience summer, some places will experience winter, some places it's during the day, some places it's at night. Why is this? This is attributed to, firstly, the concept we call revolution, and that is the fact that the sun rotates or revolves around the sun every 365.4 0.25, which is 365 and a quarter around the sun. And this rotation is the reason why we have seasons. So yeah, and notice how it's not just 365, it's 365 and a quarter, which is why every 4 years we have a leap year. But we have something called the leap year, which is an extra day. But anyways, and then we also have another concept which is called rotation, and that is the fact that the sun rotates. Just want to make sure, rotates, which is turns around its axis every 24 hours. And that is why, for example, in the USA, it would be 8 o'clock in the morning. However, in South Africa, it's now 3 o'clock in the afternoon. That is because of rotation, the fact that the sun rotates around its axis every 24 hours. And then another factor is the fact that the tilt of the earth on its axis, it's not a 90-degree tilt, it's tilted on a 23.5 degree angle. So that is another factor that contributes to the differences in like day and night and seasons and so forth. Okay, so this diagram basically shows us the significance of the Earth's axis and the revolution around the sun. So in the first image, which is what we would call at 12 o'clock, we see that the date is written 21 March. So you need to know that 21 March in the southern hemisphere. Emphasis on the southern hemisphere. That's why I said, get your notes please. 21 March in the southern hemisphere is known as the autumn equinox. Equinox because that is the date which marks the fact that it's equal day and night, you know, so equinox, and it's autumn in the southern hemisphere. However, in the northern hemisphere, it is spring. So 21 March in the northern hemisphere, they will experience something we call spring equinox. And on that day, the sun is direct over the equator, which is why we experience equal day and equal nights in areas in the northern and southern hemisphere. And then we move over to 3 o'clock, where we see it's written 21 December. And on 21 December in the southern hemisphere is known as the summer solstice. However, in winter in the northern hemisphere, it's known as the winter solstice. And because the angle of the sun is tilted away, the earth is tilted away from the sun, it receives more incoming radiation in the southern hemisphere, but less incoming radiation in the northern hemisphere, sorry. So that is why it is solstice. So the lengths of the days are not equal. So yeah, that's just that. And here the sun is directly over the Tropic of Capricorn. Remember that with the equinoxes, the sun is directly over the equator. Okay. Tropic of Capricorn gives us a summer solstice where the sun is directly over that. And then we move over to 6 o'clock, which shows us 21 September. It is essentially the opposite of what happens on 21 March. However, in the southern hemisphere, it is now spring, whereas in the northern hemisphere, it is autumn. And with an equinox, we know that the sun is directly over the equator. Please know this. You will be asked on this. I mean, it won't be a direct question, but just know this. Just know this. And then we go to 21 June, and that is known as the winter solstice in the southern hemisphere, but the summer solstice in the northern hemisphere. And on 21 June, the sun is directly over the Tropic of Cancer. 21 June, just right, 21 June, sun directly over the Tropic of Cancer, winter solstice in the southern hemisphere. And the opposite is true for the northern hemisphere. So know this. If there's one thing from this video that I would say no, it's this, because it will be examined. But yeah, let's just go into some questions so you can see how that will be examined. Okay, question 1 asks us to copy and complete the table that lists the important lines of latitude. Honestly, here I cannot explain it much because the description is already given. So yeah, firstly, the first answer would be the equator, and it's located 0 degrees north and south. Well, this is just 0. And the description is there. The second answer is the Tropic of Cancer, which is located 23.5 degrees north. And the Tropic of Capricorn is located 23.5 degrees south of the equator. The Arctic Circle is located 66.5 degrees north of the equator. And the Antarctic Circle is basically the opposite, is found 66.5 degrees south. So the descriptions are given. I will not be explaining that. Okay, so question 2 asks us to name and describe the event on the 22nd of December, and that is the summer solstice in the southern hemisphere. So here they're just asking us in Johannesburg, so you do not have to mention what's happening in the northern hemisphere, but had they not stated that it's in Johannesburg, you would have given both the answer. So yeah, and then the description there is that it's the summer solstice because firstly, the sun is directly over the Tropic of Capricorn, and also the sun is at its highest point in the sky at midday, and this basically marks the longest day of the year in the southern hemisphere. B, they asked us to name and describe the event on the 21st of June in Johannesburg, and that is the winter solstice in the southern hemisphere. And that is because the sun is directly overhead the Tropic of Cancer, which is located 23.5 degrees north of the equator. So because the sun is now more on the north, it becomes winter for us in the southern hemisphere. And the sun is at its lowest point in the sky at midday, and this is actually the shortest day of the year in the southern hemisphere. C, it says, when is the sun almost directly overhead in Johannesburg? Is it December or June? Well, you should know that this is December because during December, the sun is directly overhead the Tropic of Capricorn, which is also close to Johannesburg. So that's already another answer, which is in the southern hemisphere. And the sun is far further from the Tropic of Capricorn, so it cannot be the other answer. But yeah, just know that the main answer for that is the fact that the sun is directly over the Tropic of Capricorn, which is in the southern hemisphere. And also, if you're South African and you know that December is hot, and it's scorching, so that's another reason. But you can't just give that reason in your exam. You need to show your knowledge and your application of the lines of latitude. Next question, when does Johannesburg receive maximum insolation, in December or June? In December, obviously, because first things first, the clue is that it's summer is hot, but you can't give that answer. You need to say that, firstly, you need to define what insolation is. And for those of you who do not know, insolation is the amount of solar energy received. And because the sun is directly overhead, well, almost directly over the Tropic of Capricorn, which is close to Johannesburg, that's when we get the most sunlight and warmth. So that's the answer. As a recap of this video, the take home, what you need to know. You need to know the seasons in each hemisphere. You need to know that on 21 June, in the southern hemisphere, we experience something called the winter solstice. There's the winter. Just know the seasons in every hemisphere. Know where the sun is on the different dates. You will be examined on that, I promise you. Know the length of day and night, and also then, as I said, the solstice and the equinoxes. Know them. Know when they could ask you. Yeah, just know them. But yeah, if you do have any questions, please feel free to ask. I'm also on TikTok. You can ask the questions there. So yeah.